wondered why maths matters outside of school? Spoiler, it kind of shows up everywhere. In this video we're going to break down some key mathematical concepts clearly and simply. Whether you're studying, relearning, or just curious, you're in the right place. Please remember to like and subscribe, I really appreciate the support. Let's get into it. Two position vectors, OA is equal to minus 2, 0, 3, and OB is equal to 2, minus 3, 4. I want to find the position vector from A to B. Now, a really stock standard question, a really core part or a fundamental skill for a lot of our vectors work, and it might be something you remember from Unit 1. However, we're going to just go over a bit of a recap of our skills and look at some of the important stuff that we need to remember or recall from Unit 1. So, I want to start by, if I want to find a vector from A to B, there's a few different ways to do this. I like to think final minus initial. It's just always something that I find easy to remember, and it's also true for those of us that have some crossover with physics as well. So if I do my final point is going to be B. So I'm ending or I'm finishing at B. So I want to start with my position vector B, which is this 2, minus 3, 4 coordinate point. So my final point is 2, minus 3, and 4. And my initial point, or where I began or started from, that is going to be the coordinate point A, or this minus 2, 0, 3 coordinate point. So I'm going to subtract minus 2, 0, 3. Okay, I'm going to scroll down a little bit. When I subtract two column vectors, I do my corresponding entries. So that's going to be 2 minus negative 2. Well, 2 minus 2 is going to be equal to 2 plus 2. That is going to give me the position of 4. And if I do my second row, well, that's minus 3 minus 0. That's simply going to remain as being negative 3. And I have 4 minus 3. That is going to give 1. So my position vector is given as 4 minus 3, 1 as a column vector. Or if I want to express this as my ij's and now k values, because I'm in three-dimensional space, I could also write my answer as being 4i minus 3j plus 1 lot of k, and of course I don't need to write the 1 in front of my k. So this is all there really is to finding my position vector or my unit vector AB. I subtract my final point by my initial point. This works for every single type of vector question we get, and I can express my answer either as a column vector or as rectangular components, which is my 4i minus 3j plus k. This example focuses on subtracting two vectors in rectangular components. A is equal to 2i minus j plus k, and b is equal to negative I minus 2j minus 3k. I want to find 3a minus 2b. Now, each of my vectors have been multiplied by a scalar quantity, so we're also going to recap a little bit about how to scale our vectors and also subtract our vectors in I, j's, and k form. So, I want to start by 3a minus 2b, and I put these little squiggles underneath my a and b to show that they're vectors. Well, that's going to be 3 outside of 2i minus j plus k minus 2 outside of b, which is negative I minus 2j minus 3k. So now all I have to do is expand. That's going to be 6 lots of I minus 3 lots of j plus 3 lots of k minus, well, negative 2 times negative I is actually going to become plus 2i. And then minus 2 times negative 2 again is going to become plus 4j. And minus 2 times negative 3 is going to become plus 6k. So now once I've got all my components in I, j's, and k's, I can simply just add my I components together. I can add my j components, and I can add my k components. Well, 6i plus 2i is going to give me 8 lots of I, negative 3j plus 4j gives me plus 1 lot of j, and then 3k plus 6k gives me plus 9 lots of k. So when I'm adding two vectors or subtracting two vectors in rectangular components, I can simply just collect my I components, my j components, and my k components together, and that gives me my answer.